This is the last example, and as you can see that our equations are a little bit different this time. In the previous examples, all of our functions were y equals f of x. This is an example where our equations are given to us in terms of y. X equals a function of y. So how to visualize this when you're graphing it? I mean, these are parabolas. Y squared, negative y squared. It's just like drawing parabolas, but instead of drawing them up or down, when this is x squared, this is negative x squared, you're going to draw them going to the right, this is positive y squared, or to the left, negative y squared. So let's go ahead and draw this picture real quick of what this will look like. Now what we can do to help us is factor out a y. We get y squared, or not y squared, y minus 4 on this one, and we get 2 minus y on that one. From here we can easily see the zeros. They both have a 0 at 0. One of them has a 0 at 4, so 1, 2, 3, 4. The other one has a 0 at 2. So let me go ahead and draw these real quick. See, this one will be in red. If you notice, it's a positive y squared. It's going to open up in the positive direction, and it looks something like this. Now I'll do the other one in blue. It's a negative y squared. It goes through these zeros because that's where this 0 came from. And it looks something like that. So the area that we are trying to compute, the area between the two curves, is right here. So we can go ahead and write our integral now. With the exception, we don't know what this value is, d. So we're going from c equals 0 to d equals something. Now to figure out that point, we do the same exact thing. We're going to set the two equations equal to one another. Y squared minus 4y is equal to 2y minus y squared. And we're just going to solve. So I'm going to add y squared minus 2y, add y squared minus 2y. All that cancels. And we get 2y squared minus 6y equals 0. From here, I can factor out a 2y. I get a y minus 3 equals 0. And we can see that y is equal to 0 and y is equal to 3. So where they intersect right here is at y equals 3. So here's what we're going to do. We're going to write the integral. So the integral from 0 to 3. Now, normally it's the upper function minus the lower function. So the upper function is always the positive function. The lower function is always the negative function. If you think about going left and right, this is the positive x-axis, this is the negative x-axis. So the positive function is going to be the one on the right, the negative function is going to be the one on the left. So when you're doing integrals in terms of y's, you always want to do the right function minus the left function. That's analogous to the top function minus the bottom function. So the right function is the blue one. So it's 2y minus y squared minus the lower function, and I'm putting it in parentheses because that minus sign has to distribute to the entire function. Here's our lower function, y squared minus 4y. Alright, so now we have everything we need. We don't need the picture anymore. We have our integral. We could simplify that integral a little bit by putting together like terms. So integral 0 to 3, and it's going to be a 6y minus 2y squared. 2y minus a minus is a plus. 2y plus 4y is 6y. Minus y squared minus another y squared is minus 2y squared. And then all of this dy. So now just find the antiderivative. Going up one power, you get a squared. Divide this number by that power, you get a 3. minus, go up 1 power, you get a cube, and then divide the coefficient by that power. I'm going to evaluate this from 0 to 3. Now, since this is a polynomial, we don't have to evaluate at 0 because the lower bound is going to go away. All we have to do is evaluate at the upper bound. 3 times 3 squared minus 2 over 3 times 3 cubed. This is equal to, this is a 9, 3 squared is 9, times another 3 is 27, minus 2/3 times 27. Well, that's 27 minus 2/3 times 27 is 18. Well, this equals 9. So the entire area enclosed by these two curves is equal to 9. So that's it for 6.1. You should go ahead and try the problem that I gave you guys. It's find the area between the two curves, just exactly like how we did here. The lower and upper limits of integration are given. You just need to decide what's the upper curve and what's the lower curve.